Hello students, today in this video we will learn about trusses. What is truss? Truss is basically a structural unit in which all the members are pin jointed and carries tension and compression only. There is no bending in any of the truss members. Trusses are basically used in building roofs, bridges, towers, etc. There are few conditions for any of the structural unit to be called as truss. First condition is each and every member should be pin jointed, and second condition is loading at joints only. So this structure is truss. This structure will not term as truss because here loading is not at the joints. This loading is at the center, which will cause bending in this member. But truss carries only tension and compression. So now let's move to the part number of members required in a truss, which is given by relation m equals to 2j minus 3, where m is number of members, j is number of joints. Here if m is less than 2j minus 3, then truss is called as deficit truss, and if m equals to 2j minus 3, then it's a perfect truss. Now moving to the analysis part of the truss. Analysis of truss means finding out each and every member forces in a truss, and we have two methods to finding those forces. First one is method of joints and second is method of sections. In any of these two methods, first we calculate support reactions by taking equilibrium of whole structure, that is summation fx equals to 0, summation fy equals to 0 and summation m equals to 0. And then in method of joints, we take equilibrium of a point by considering all the forces passing through this point, and then resolving all these forces in x and y directions. Then we calculate unknown forces by summation f of x equals to 0, summation fy equals to 0. And method of sections, we cut a section in a truss through which that member should be passed in which force is to be calculated, and then taking equilibrium of that part of truss only, either left to the section or right to the section. So let's understand these two methods by taking examples. First is method of joints. Taking this example for method of joints, this is truss ABCDE having this load vertically downward W and A as hinge support, E as roller support. We need to find forces in FBC and force in member CD. Step 1 is finding reaction by taking equilibrium of whole structure, that is summation of total vertical forces, summation Fx equals to 0 and summation m equals to 0. Let's assume these reactions horizontal as HA, this reaction as HE. There will be no vertical reaction because it's a roller support. This vertical reaction at point A is VA. First taking vertical forces only. Vertical forces are this VA in upward direction and this W in downward direction equals to 0. So VA equals to W. Now taking total horizontal forces, that is HA plus HE equals to 0. So HA equals to minus of HE. And now I am taking moment of equilibrium at point A, that is equals to 0. Here I will take moment of all the forces about this point A. These two forces will pass through this point A, so these will not give any moment, and this W will give clockwise moment, that is W by 6. And this HE will give anti-clockwise moment about this point A, that is minus HE by 4 equals to 0. By solving this equation, we will get HE equals to 1.5 of W and HA will be minus of 1.5 W. Now we need to find out forces FBC and of FCD. So we will take equilibrium of this point C by drawing FBD of joint C. This is point C. Here a W in downward direction. This is FBC and this force FCD. Taking this angle as theta and dissolving this FBC into X and Y directions, then dissolved FBD will be W in downward direction. This will be FBC sine theta. Showing this FCD here, and this will be component of this force FBC cos theta. Now taking equilibrium of joint C, that is summation Fy equals to 0 and summation Fx equals to 0. Vertical forces are Fbc sin theta in upward direction and downward force W minus W equals to 0. So Fbc sin theta equals to W. For theta we have this triangular part of truss. This is 3 meter, 4 meter and 5 meter, and this is angle theta. So sin theta will be 4 by 5. Then FBC multiplied by 4 by 5 equals to W. FBC is 5 by 4 of W. And summation f of x equals to 0, that is FCD minus this force minus FBC cos theta equals to 0. That is FCD equals to FBC cos theta. Here cos theta will be 3 by 5. So FCD equals to FBC, that is 5 by 4 of W, multiplied by cos theta, that is 3 by 5. So FCD is 0.75 W. So we calculated these forces by method of joints. Let's take another example for method of sections. Taking this example 2 by method of sections, the given truss is A, B, C, D, E, F, and we need to find force FCF by method of sections. In first step, we need to calculate reactions of supports that we can calculate as we did in method of joints. But here it's a symmetrical structure and loading is also symmetrical. So these two vertical reactions will be same, that is VC and VD will be same. And as there is no external horizontal loading and this is a roller support, so there will be no horizontal forces, and this HC will be 0. So we can write HC is 0 and VC equals to VD equals to 10 kilonewton. In this problem we need to find force in FCF. So I am taking this section which contains this member CF, and I'm drawing the only right part of this section. So this is right part of the section containing all the forces crossing this section, that is FCF, FAF and FCD. And now write the equilibrium equation of this part of the truss, that is right to the section, which is summation Fx equals to 0. Horizontal forces are FAF and component of this FCF, if I'm taking this as theta, FCF cos theta and FCD. So we can write minus FAF minus FCF cos theta and minus FCD equals to 0. That is FAF plus FCF cos theta plus FCD equals to 0. And now summation Fy equals to 0 for this part of truss. Vertical forces are this vertical reaction Vd, that is in upward direction, and this downward force of 10 kilonewton, and we'll take the component of this force FCF as FCF sin theta, that is also in downward direction, minus FCF sin theta equals to 0. Vd is 10 kilonewton minus 10 equals to FCF sin theta. So this 10 minus 10 will be 0. So FCF will become 0. We require FCF in this question, but we can calculate force in any of these numbers by taking force and moment equilibrium at suitable points. So it was all about trusses for today. Thanks for watching.